Good afternoon. Uh, Last week we were looking into polynomial division, where we had different modes in the case of log and synthetic division, and then we crossed over to the continuation of that, where we looked into determining the domain and asymptotes, particular rational functions, and we're going to cross over again to polynomial inequalities, which was where we had left off last time. But I just want to sort of step back for a moment, where we have in looking at determining the domain and asymptotes. And let's say if we have a rational function r of x is equal to 4x squared plus 10x plus 1 all over the binomial 2x plus 1. Okay, and on the side of what we have for the domain, okay, again, for a rational function, okay, the denominator cannot be 0 in value. Okay, so we have with the denominator at 2x plus 1, okay, with it not allowed to be equal to 0, okay, we can solve for x, and if we isolate the variable term 2x, we're going to have that this term cannot equal negative 1. And looking at expressing in terms of x, so if we divide both sides by 2, okay, we're going to have that x cannot be negative 1/2. And so for what we will have in the case of the domain, okay, there's only one exclusion, so for the domain we have those values of x less than negative 1/2, as well as those values of x which will be greater than negative 1/2. Now we have with this rational function, okay, now the numerator cannot be factored, okay, and 2x plus 1 is not going to be a factor of the numerator in r of x. And so r of x, okay, this is already simplified, or already in simplest terms. So this is going to mean that the exclusion from the domain is going to be the vertical asymptote. Okay, so with x not equal to negative 1/2, and since the rational function is already in simplest terms, okay, we're going to have a vertical asymptote at x is equal to minus 1/2. And for what we have concerning any other kind of asymptote, once again, this is going to come down to the comparison of degrees and what we have in the numerator and denominator. Okay. So we have now, okay, we've got in the numerator, okay, the highest order term is 4x squared. So the degree of the numerator is going to be at 2. And in the denominator, the higher order term is 2x, okay, which is going to be at first degree. So we have that m is equal to 1, and here we're going to have that n is greater than m by 1 degree. And if the numerator degree is greater than that of the denominator, okay, we're going to have a slant asymptote. Okay, and we're going to have y is equal to some linear expression, and that linear expression is going to be derived from what we have in the case of 2x plus 1 divided into 4x squared plus 10x plus 1. So looking at what we have in the setup, okay, so we have 2x plus 1 taken into 4x squared plus 10x plus 1. Okay, so we do not have any missing degree terms. Okay, now the divisor is linear, okay, but instead of having just x as a leading term, okay, we got 2x, and I can't go directly into synthetic division without just adjusting the coefficients of all that we have between the divisor and the dividend. Okay, so we'll just proceed with the log division. Okay, so we got for 2x into 4x squared, okay, or 4x squared divided by 2x. Okay, that is going to be at 2x, and distributing over the divisor. Okay, we have 2x times the quantity of 2x plus 1. So this is going to be 4x squared plus 2x. And after the first round, okay, we're going to be subtracting the product from the like terms in the dividend. So we're going to have 4x squares to go out. Now we have 10x minus 2x. It's going to be 8x. And then we can bring down the plus 1. Now we got 2x, again the leading term from the divisor, and we have into the leading term, okay, originating from the dividend after the first round of log division. So we got 8x divided by 2x. Okay, so that will go 4 times, and distributing we'll have 8x plus 4 and taking the difference once more. So we'll have 8x's to go out, and we have 1 minus 4. Okay, so that is going to be at negative 3. Okay, and I cannot take 2x directly into negative 3, so negative 3 would be the remainder. Okay, but I'm interested in just the quotient in terms of identifying what the slant asymptote is going to be, and with 2x plus 4 as the quotient, we have our slant asymptote at y is equal to 2x plus 4. Okay, so we have two asymptotes, one vertical and the other a slant asymptote, and just providing a bit of a quick visual. And so just looking at what we have in this case, let's see if I can. Yeah, here we go. Okay, so we got in this one. So let me give you one that's probably a better capture. Here we go. All right. So we have here. Okay, so you have r of x. Okay, we have equal to 4x squared plus 10x plus 1 all over 2x plus 1. And included, we can have like sets of ordered pairs in the mix. Okay, now you have for the curves in red, those are in reference to the graph of the rational function. And again, we have split up, okay, by the vertical asymptote, which we have at x is equal to -1/2, and running alongside, okay, these curves to the extreme left and the extreme right. Okay, we have the slant asymptote at y is equal to 2x plus 4, and what I've done is include some ordered pairs. Okay, so among your ordered pairs, you have like -3, -1.4, -2, 1, -1, 5, and all three of these sets of coordinates will be to the left of the vertical asymptote, and to the right. Okay, so I have 0, 1, which is on the y-axis, and also on the graph of the rational functions right half portion, Then we have 1, 5, and also 2 and 7.4. Okay, just to name a few of these particular points. And so again, this is a final case of what we have with rational functions and the corresponding asymptotes. All right, now in crossing over to what we have for polynomial inequalities, again going back to our less than or equal to, as well as the greater than and greater than or equal to statements. Okay, and there'll be some items that we'll set up in terms of comparing to 0. And there'll be some parts that might get pretty straightforward, and there'll be some of the mechanics involved that can get to be pretty dry, you know, but it is highly procedural all in all. Okay, and so just for what we have in the case of polynomial inequalities, and we can say that for instance, okay, let's say just kind of using as building blocks. Okay, say if I were to solve for x, okay, and just sort of laying down the bricks, and then just kind of use the figuratively speaking, the mortar that will kind of put the bricks together, and in terms of how the equations and the inequalities relate. And let's say if we have, first of all, say we have an equation that's not quite in standard form, where we have x squared plus 6x is equal to 16. And then let's say if we start to take these terms and put them in terms of inequalities. So we have x squared plus 6x is less than 16. And we have x squared plus 6x is less than or equal to 16. And then changing direction. So we have x squared plus 6x is greater than 16. And then we have for our remaining possible inequality, okay, we have where x squared plus 6x is greater than or equal to 16. All right. So if we look at these items, okay, so for the first we have a quadratic equation. And for x squared plus 6x equal to 16, I can just put what I have here in terms of establishing zeros that we can use in setting up a table, okay, that will concern the possibilities that we have among the inequalities. Okay, so for the standard form of the quadratic equation, okay, that we have in the first case, all right, so we have x squared plus 6x minus 16 is equal to 0. And if I look at factoring, okay, so we got with the factors here. Okay, so for factors, negative 16, whose sum or difference will be on the plus side at 6. Okay, more weight is given to the addition than to the subtraction. And on the side of addition, okay, we have x plus 8. And if I set this factor equal to 0, okay, so we're going to have that x is equal to negative 8. And for what we have in the case of x minus 2, if I set this equal to 0, okay, so we have that x is equal to 2. And okay, so we have with our solutions in x, okay, we have negative 8 and positive 2. All right. Now, for what we have in the case of numbers 2 through 5. All right. So again, we have as what we have among these inequalities. Again, we're going to be working with the zeros. Okay, and now we're going to have working around these inequalities. Again, we'll have that f of x is equal to x squared plus 6x minus 16 and for the zeros of f of x. Okay, so you're going to have at x equal to -8 and also at x equal to 2. And just looking at establishing tables. Okay, so I'm going to set up a row of intervals. Okay, now we have with our zeros, we have -8 and +2. And if I kind of run it through essentially the real number system. Okay, so -8 is the smaller of the zeros. So I have between -8 and -infinity. Then for the next set, I have between -8 and +2, and with 2 being the second and last of the zeros. Okay, we have the rest of the possible values of x might be somewhere between 2 and infinity. Okay, so again, for the intervals set up in the table, we're going to have the exclusive use of parentheses. And now again, we'll have a row, okay, that's going to consist of test values for the input, and just refer to this as test value x. And also again, we have this quadratic function. So we have f of x is equal to x squared plus 6x minus 16 . Okay, so in setting up the table, again, I'm going to partition the interval sections. Okay, so for test values, okay, say like we have anything selected less than -8, okay, for the tested value, okay, as long as it's less than -8, you're fine. Okay, and I like to keep the absolute value as low as possible. We'll go with -9. And between -8 and 2, I can have like anything, should I stick with the integers, from and including -7 all the way up to 1. And for here, I'll just go with 0. And then anything greater than 2, I can just go with the number 3. Okay, and this is our function. And here we have with the outputs. Okay, we'll have these established from f of -9, f of 0, and f of 3. Okay, so with x at negative 9, f of negative 9, okay, we're going to have the square of negative 9 plus 6 times negative 9 minus 16, and the square of negative 9. Okay, so this will be 81. 6 times negative 9 is negative 54. 81 minus 54 is 27. Minus 16. And so f of negative 9, okay, comes out to positive 11. Now for f of 0, running through the same operation. So you have 0 squared, 6 times 0. Okay, so you have first two terms resulting will be negligible. And so for f of 0, with the subtraction of 16 to follow, okay, we have the f of 0 equals negative 16. Now for f of 3, we have 3 squared plus 6 times 3 minus 16, and 3 squared is 9. 6 times 3 is 18. 9 plus 18 is 27 minus 16. And we had the same output at x equals 3 that we did whenever x was negative 9, so we have also a positive 11. And in terms of the sign value of f of x, so in the first, okay, anything we select that is less than negative 8, like negative 9 for instance, you're going to have a positive output. And with positive outputs, you're going to have the f of x is greater than 0. Anything between negative 8 and positive 2, but not including negative 8 or 2, the output is going to be negative. So we're going to have the f of x is less than 0, and any value that we select for x that is greater than 2, we're going to have a positive output. Okay, so we're going to have that f of x is greater than 0. And just looking at taking...
I'm sorry, can I interrupt you?
Yeah.
That first one where you have the negative 9
Uh-huh.
sign over there, I'm confused as to why that's... I may just be
Okay, remember,
not comprehending it. It says greater than 0, but negative 9 isn't greater, so...
negative 9, okay, you're looking at negative 9 is less than negative 8. Think of like a number line. Okay, we got your zeros. Okay, so you got like... Okay, so you got like with the numbers select, so you have like, got negative 9, you got 0, and you got 3. So anything that's between negative infinity and negative 8, but not including negative 8. Okay, negative 9 is a possibility. I could have chosen like negative 20, for instance. And say like between negative 8 and positive 2, like 0 lies in between. But I could have chosen, say, like negative 6 or negative 5. And then anything greater than 2, you know, anything to the right or 2 on a number line, okay, that is going to be a possible test value. And so just whatever I select, if I run those selected values as the inputs for this given function, like anything that is less than negative 8, think of like negative 9, 0, and 3 are going to be like your x values. If you think of like the xy coordinate system, and if I were to literally plot, and we'll be looking into some of those cases, like a point on the graph of y is equal to f of x equals x squared plus 6x minus 16 is going to be at negative 9, 11. Like negative 9, 11 would literally be a point on the graph of this function. And we would have like
Okay.
0, negative 16, and also we have 3, 11. So in other words,
I think I was mixing up f of x and just x.
okay, gotcha.
So I think I was thinking it was supposed to be anything greater than -9
Right, okay, gotcha.
instead of it being the 11. Okay, thanks.
Okay, now for, again, just taking what we have for the inequalities. Okay, so again we had x squared okay, so x squared plus 6x is less than 16. Again, if I were to translate as comparison to 0 inequalities, so for parts 2 through 5, again, in comparison to 0 terms, okay, so I'm just moving the 16 over by subtracting, just like I did with the first part where we had just the quadratic equation. But just putting this in a context where I can make the table, putting it in terms that are readable. Okay, again, just going back, okay, we had that f of x equals x squared plus 6x minus 16. Okay, so for what you have from the table, okay, so you have, again, so f of x, you have x squared plus 6x minus 16, and first case, if this is less than 0, this is going to make reference to f of x is less than 0. Third statement, we have in reference to f of x is less than or equal to 0. And just changing directions, okay, where we have f of x is greater than 0. And where we have f of x is greater than or equal to 0. Okay, now if you notice, we have in the bottom row, okay, we have greater than 0, less than 0, greater than 0. And if we go ahead and just take care of the less than 0 and the greater than 0 parts, okay, so where we have this statement to translate out to ultimately where f of x is less than 0, so this will be in the middle section, and where those values of x, okay, will be described in the top row, same column. Okay, so the solution in this case would be those values of x such that -8 is less than x, which in turn is going to be less than 2. And for what we have for f of x is greater than 0, okay, notice we have greater than 0 with the first and the third interval sections. So we have, first time that we have that f of x is greater than 0, this will come from, again, the first column where we have negative infinity approaching but not including -8. So 1/2 of the solution, you have those values of x less than -8, and the other half we're going to have those values of x greater than 2. So again, you have negative 8 to 2. And again, where f of x is greater than 0, we're looking at the first and the last sections. All right, now where we have less than or equal to 0 as well as greater than or equal to 0. Okay, now we're going to have involvement of the same limit values that correspond to where we have, at least in the where the inequality is pointing in the same direction. Okay, so this time around, okay, so you have less than or equal to 0, same direction as f of x is less than 0. Now we're going to involve the same limit values. In this case, you have negative 8 and 2. The difference is going to be in the grouping symbols, because we were looking exclusively at less than 0 before, but now we're looking at not only less than 0 but also equal to 0. And for those values that set the equality, okay, we're going to be negative 8 and 2, and so around those values will be brackets. And we had that bit of history again with greater than or equal to 0. Negative 8 and 2 are going to have the same treatment, since they are the only values that will create the equal portion. So for this last inequality, okay, now infinities are still going to be boundless, and we will again have parentheses. Again, here we have the equal portion satisfied. Okay, that will be made possible with negative 8 and positive 2. So we have putting together. Okay, now again, when we had x squared plus 6x is equal to 16, we had the values of x at negative 8 and 2. And for the inequalities, putting in terms of f of x, we have these respective solutions for x. Okay, for x squared plus 16 is less than 16, less than or equal to 16, as well as greater than or equal to 16. So for the first and second sets, you had involving the same limit values, but whether the finite amounts of negative 8 and 2 are going to be bracketed or not is contingent upon whether the inequality has the equal sign or not. All right. Now, in looking at what we have as a case, and I'll tell you what, for the next few moments, looking at solving for one particular inequality. Let's see what we get in solving for x in the inequality where we're going to have x squared minus 4x is greater than or equal to 32. Okay, so the next few minutes. Okay, let's see what we get for the values of x such that x squared minus 4x is greater than or equal to 32. Okay, if you're still working on this, that's fine. But again, we have x squared minus 4x is greater than or equal to 32. And we can rewrite what we have here in terms of a comparison to 0 inequality. And we can also establish, okay, what f of x is going to be, as well as what the corresponding zeros would be. All right, so if I put this inequality in terms of a quadratic equation, okay, not yet in standard form. So if I have that x squared minus 4x is equal to 32, what I can do is I can just take 32 away from both sides and just put this equation in standard form. So we have x squared minus 4x minus 32 is equal to 0. And looking at factoring and utilizing the zero product property. Okay, so we're going to have more weight given to the subtraction than the addition. So we have x plus 4 and x minus 8. And if I utilize, okay, the zero product property, so we have from x plus 4, if I set this equal to 0, we'll have that x is equal to negative 4. And for x minus 8, if I set this to 0, I'm going to have that x is equal to 8. Right. And so we would have for our solutions, okay, so we would have negative 4 and positive 8. And looking at, again, just transition what I started out with and setting in standard form. So this x squared minus 4x minus 32, we have this to represent f of x. Again, with x at negative 4 and 8, okay, those are going to be the zeros of f of x. So for what we have in this inequality, okay, so if I rewrite in terms of comparison to 0, so I would have x squared minus 4x minus 32 is greater than or equal to 0. And again, so this is going to be in terms of f of x is greater than or equal to 0. I'm just restating. Okay, so I have, again, f of x, you have x squared minus 4x minus 32. And again, the zeros will be working around. Okay, we have a negative 4 and positive 8. And setting up a table. And working around the x values of negative 4 and 8. Okay, as well as the real number system. Okay, so I have negative 4 is the smaller of the two zeros. So we have at the starting end, okay, we have those values of x less than negative 4. Then I have in between, I have those values of x such that negative 4 is less than x is less than 8. And bypassing 8, we have those values of x that would be greater than 8. And again, just establishing the intervals and just sample inputs that we can use. Okay. Okay, so we have for first interval section, okay, we have anything less than negative 4, we can go with negative 5. And between negative 4 and 8, okay, 0 is a possible value. And anything greater than 8, okay, 9 will fit the bill. Now once again, separating the rows and the columns. Or separating into rows and columns. Okay, again, we got our tested value x. And now looking at the sign value of the resulting f of x. Okay, so we have x squared minus 4x minus 32. And plugging in the values of -5, 0, and 9. Okay, so at -5, okay, so we got the square root of -5. We got minus 4 times -5. Okay, minus 32. Okay, -5 squared. Okay, so this would be 25. -4 times -5, this would be a positive 20, so we have 25 plus 20, which is 45. And if we take away 32, so we're going to be on the plus side at 13. Now for f of 0, okay, plugging in 0, so we got 0 squared is 0, minus 4 times 0, which is still 0, and we have minus 32, and the end result is going to be -32. And for f of 9, okay, so we're going to have 9 squared minus 4 times 9 minus 32. Now 9 squared is 81. -4 times 9 is -36. 81 minus 36 is 45. And for 45 minus 32, okay, this is going to come out to positive 13. Yes.
Yes, Mr. Strickler.
Uh-huh.
Are you going to post this for your test review? Because I'm a little bit confused on how the graph goes.
Okay. Okay. Now for this one, okay. Now for the inequalities, you don't have to. We're not going to graph these right away. We're just setting up the table.
Okay.
Yeah. But there is a part that's going to be concerning, okay, like what region will the graphic inequality be above the x-axis as well as below the x-axis, and this is where the positives and negatives concerning the y values will fall into play. Okay. All right, so but right now just look at it from a horizontal line perspective. Okay, so you got like -5 is like to the left of -4, and 0 you have between -4 and 8, and we have between 8 and infinity you have like 9 is one among many values. Okay, they'll be to the right of 8, and just looking at again what would be the corresponding y values. So you have like when x is -5, your y is going to be f of -5. So I'm just looking at the function values right now. So like anything less than -4, we have -5 as an input, and the corresponding y value, like 13 being the case, is going to come out to a positive amount. Okay, so your y, or f of x value, this will come out to a positive. And anything that we have between -4 and 8, but not including -4 or 8, okay, that's going to result in a negative output. Okay, so you have f of x is less than 0, and then anything that is greater than 8, okay, the output is going to be positive. So we have that f of x is greater than 0. Okay. And looking at what we have with the original inequality, again, this is with x squared minus 4x is greater than or equal to 32. So just duplicating. Okay, so we got this inequality. And just for the, again, just the progression, okay, so you had x squared minus 4x is greater than or equal to 32. As a comparison to 0 inequality, again, I took 32 away from both sides. And again, just in terms of how f of x compares to 0. Okay, and so for f of x is greater than or equal to 0, okay, we'll have in the case of the solution. Now, in terms of the direction, okay, so you have greater than or equal to 0, and it's going to be in the same direction as what we have with f of x is greater than 0. Alright, so just looking at what we have in the case of the potential limits. Okay, so from greater than 0, we're involving, at the lower end, we have negative infinity and negative 4. And also we have those values of x between 8 and infinity. Again, I selected those values since we have the greater than portion represented. Okay, and for the enclosure, now, regardless of whether the inequality is greater than, less than, greater than or equal to, less than or equal to, if you have infinities involved, again, infinities are boundless, so they're going to stay in parentheses. Now for negative 4 and 8, again, negative 4 and 8 create the equal to portion, and so, and since negative 4 and 8 are going to be included in the solution thanks to the equal sign, and because they set the function equal to 0, negative 4 and 8 are going to be in the bracket. If I did not have the equal sign, we would have had parentheses throughout, but in this case, again, thanks to the equal sign, we have negative 4 is in the bracket, as is the number 8. All right. Now, looking at what we have in terms of setting up zeros. Okay, this is going to look like yet another common example, but I just want to kind of bring this up just to kind of illustrate that, okay, you want to avoid any potential careless mistakes. And let's say that if you're looking at solving for x, and we'll say that we have x squared plus 6x, okay, is less than 0. So you have x squared plus 6x is less than 0. So if there are to be any solutions for x, and we had to apply grouping symbols, you would have just parentheses to use, okay, since we don't have the equal to sign involved. Okay, now let's say that if I were to identify the zeros, okay, so you already have the inequality in comparison to 0 terms. Now we have x squared plus 6x is equal to 0. And if I factor, the greatest common factor is only x. Okay, so I have x times the quantity of x plus 6 is equal to 0. And if I look at utilizing, again, the zero product property, okay, so I have x as its own factor, and we'll have already a solution established at 0. And for the x plus 6 part, if I set this equal to 0, then we'll have that x is equal to negative 6. Okay. So we got here that x is 0 is one solution, x equals negative 6 is going to be the other. Now, again, just taking what we have from the start. Okay, so we already have the variable expression compared to 0 from the start. So it's already going to be baked in that f of x is equal to x squared plus 6x. And for the zeros of f of x, you have your resulting x values from the quadratic equation. Okay, so we have 0 and negative 6. Now, where the inequality is concerned, okay, so you have x squared plus 6x is less than 0. And again, x squared plus 6x represents f of x. So again, we're just going to be looking at in the table terms, okay, where f of x is less than 0. Okay, so this is what we have for f of x, and these are the zeros we're going to be working around. Okay, and what I mean by avoiding any careless mistakes. Okay, now if I establish the intervals, okay, now I got 0 in front of the negative 6, but remember, we're going to arrange, okay, where you have going from negative infinity to the smaller or smallest of the zeros. Okay, in this case, between 0 and negative 6. Now, on a number line, negative 6 will be to the left of 0, and so we're going to go from negative infinity and approaching, but not including, negative 6. And then we have negative 6 is going to be bypassed. So we have going from negative 6 approaching 0. And for the rest of the set, you have those values x, which will be greater than 0. Okay, so you have just like concepts you have throughout the real number system. Okay, so you just have like referencing negative 6 and 0. Alright, so you have, again, values of x less than negative 6, those between negative 6 and 0, and those greater than 0. And for tested values, we can place so anything less than negative 6, just as long as it's less than negative 6, we'll go with negative 7. Anything between negative 6 and 0, we say something like, we'll say negative 3. And anything greater than 0, we'll just go with the number 1. And again we have f of x is equal to x squared plus 6x and to establish our table, okay, and just splitting into rows and columns. Okay, so we have, first of all, okay, so we got with our first tested value to input at -7. So we have our f of -7. So we have for f of x equal to x squared plus 6 times x, and we have the square of -7 plus 6 times -7, and the square of -7. -7 times itself is positive 49. 6 times -7 is a -42. And 49 minus 42. Okay, this will come out to a positive 7. If I go with f of -3. So in the procedure, so I have the square of -3 plus 6 times -3. Square of -3 is positive 9. 6 times -3 is -18. And 9 minus 18, that'll be a -9. And for f of 1, okay, so we have 1 squared plus 6 times 1. 1 squared is 1. And we're going to have 1 plus 6. And that output is also going to end up at 7. And for what we have in the case of the sign value of f of x, okay, so you've got a positive. So you have the f of x is greater than 0, anything selected between -6 and 0, but not including -6 or 0. Output is going to be negative, whereupon we're going to have the f of x is less than 0, and anything greater than 0, we select any positive value for the input. The output is also going to be positive. So we will again have it that f of x is greater than 0. So for the inequality we're working with, okay, so again we have x squared plus 6x is less than 0. Again, this is going to make reference to where f of x is less than 0. And so for what we will have in the case of the solution, okay, so where f of x is less than 0, so we have from the top row, the corresponding values of x be such that -6 is less than x, which in turn is going to be less than 0. All right, so it'll be that middle interval section. All right, now, and let's say that if we have an inequality, see, we have that x squared minus 3x is greater than or equal to 18. So if I'm looking for the zeros, okay, so if I just set this up in terms of a quadratic equation, so I have x squared minus 3x is equal to 18. And if I put in standard form, so I have x squared minus 3x minus 18 is equal to 0. And looking for the solutions we have upon utilizing, okay, what we have with the zero product property. So if x minus 6 is equal to 0, so we have that x is equal to 6. From x plus 3, we have x is equal to negative 3. And again, just for the f of x are concerned. Okay, so it'll be that in the rewrite, which we have in comparing to 0 or equaling 0. So we have your f of x set to x squared minus 3x minus 18 and for the zeros of f of x, again we have it 6 and negative 3. Okay, so referencing what we have with the inequality. Okay, so again, just rewriting in terms of comparing to 0. So we have x squared minus 3x minus 18 is greater than or equal to 0. And so this leads up to, okay, so this is your f of x. So you have the f of x is greater than or equal to 0. And again, just restating okay, so we got the zeros at 6 and negative 3. Okay, so and setting up our intervals. Okay, so we got zeros at 6 and negative 3. Again, if I rank order, so I'm going between negative infinity and negative 3. Since negative 3 is the smaller, then I have between negative 3 and 6. And with 6 as the larger and the last of the zeros, we have for the remaining interval, we have those values of x greater than 6. Okay. And just looking at the tested values we can apply. Okay, so anything less than negative 3, negative 4 is a possibility. Between negative 3 and 6, okay, 0 is a possible value. Anything greater than 6, and just go with the number 7. And again, we have with f of x, then we have equal to x squared minus 3x minus 18. And again, just determining the values of the outputs. Okay, so we have in the case of f of negative 4, okay, so we have the square of negative 4 minus 3 times negative 4 minus 18. Square of negative 4 is 16. Negative 3 times negative 4 is going to be a positive 12. 16 plus 12 is 28 minus 18, so we have a positive difference at 10. Now for f of 0, okay, so here we have 0 squared minus 3 times 0, still negligible. And once we take 18 away, okay, we have for this result, okay, this will be a minus 18. And for f of 7, okay, so we got 7 squared minus 3 times 7 minus 18. 7 squared is 49. Negative 3 times 7 is negative 21. And see, 49 minus 21 is 28 minus 18. And this will come out also to positive 10. So just looking at what we have in terms of the sign values. So for anything that we select that is in x, okay, what is less than negative 3, okay, we're going to end up with a positive output. Okay, now for what we have in the case of the sign, of f of x again. First case, all right, we have a positive. So we have that f of x is greater than 0, then between negative 3 and 6, we have a negative, so we have the f of x is less than 0, and in the last case, okay, we have a positive. So we have that f of x is greater than 0. And now looking at what we have for the inequality, okay, we have x squared minus 3x is greater than or equal to 18. And again, this led up to x squared minus 3x minus 18 is greater than or equal to 0. Again, so this will lead up to where we have f of x is greater than or equal to 0. And for what we're going to have in the case of the solution. Okay, so greater than or equal to 0, same direction as greater than 0. So we have involving negative infinity and negative 3, and also 6 and infinity. And again, with the equal sign, okay, there could be brackets, okay, but now for infinities, negative and positive, we have parentheses exclusively. And the negative 3 and the 6, okay, set or create the equal to part, and negative 3 and 6 are part of the solution. And so those are going to be in the bracket. All right. And now, just a case, and I'm going to kind of hold off on this one, but there's going to be a special situation. And these items we're going to be looking into, say you have working with x squared minus 4x plus 4 is equal to 0. Okay, so just some items, okay, for next time. You're looking at what we have in comparison to 0.